Okay, everyone, hiya. So today we're going to talk about the discriminant. So what is the discriminant? Well, for starters, the discriminant formula is b squared minus 4ac, where your quadratic ax squared plus bx plus c, so this is any generic quadratic, okay, equals 0. So this is a really important point here because what the discriminant does is it tells you how many times, if at all, a quadratic will cross the x-axis. And it's very important to understand straight away that this equals 0 means a simultaneous equation between some quadratic, so here's a quadratic here, okay, so this is one curve, and when does that curve equal the, again, the line, so the equation y equals 0. So this is its own y, isn't it? This is y equals this, and this is also y equals this. So y equals 0 is here, and this is the x-axis. And y equals ax squared plus bx plus c is here. So what we need to understand and maybe this hasn't been said to you in these terms before, is that any time you have a quadratic, let's say 2x squared minus 4x equals 7, right? You cannot use the discriminant formula at the moment because this is not in the form of equaling 0. So what you have at the moment here is this graph 2x squared minus 4x. So this is a quadratic, and 2x squared minus 4x is going to look like, what's that? So you could take out x as well, so sorry, 2x, x take 2. So it's going to cross at 0, and it's going to cross at 2. So this is what 2x squared minus 4x is going to look like. And that's on the left-hand side. And on the right-hand side, you're looking at y equals 7. So here y equals 7 is simultaneously being solved with y equals 2x squared minus 4x. So here's your 2x squared minus 4x, and y equals 7 is actually here. So where do these things cross? They cross here and here. But you can't work out where those things cross until you set the whole thing equal to 0. So you move that 7 over to the left-hand side. Because in a sense, what you're doing is you're creating a new curve, and we'll talk about this more when you're in A level. So 2x squared minus 4x takes 7. If you look at it, this curve will cross the x-axis in exactly the same place that 2x squared minus 4x crosses y equals 7. So it will cross here and here, okay, matching these blue points as before. That's an important distinction to note, and that's kind of the history behind how a discriminant works and how you're going to solve quadratics. Okay, so for now, keep it simple, Scott. So b squared minus 4ac is your discriminant. Where can you find the discriminant? And where does that come from? Well, you know from the quadratic formula that x is minus b plus or minus b squared minus 4ac all over 2a, where, again, remember it has to equal 0, so ax squared plus bx plus c equals 0. This formula can only be applied when your quadratic equals 0, and the discriminant can only be applied once your quadratic equals 0, okay? And you can see then that this discriminant is this section here in your square root. And this tells us why it matters if the discriminant equals 0, or it's less than 0, or it's more than 0, and what that means. So let's look at first if the discriminant is less than 0. Alright, so if b squared minus 4ac is less than 0, then that means this part inside, if that was less than 0, then you'd be square rooting a negative number, which, as you know, you can't do to real numbers. You can't square root a negative. So therefore, this would translate to having no real roots. And remember what that means. That means the graph does not cross the x-axis. Right? So no real roots, because you can't square root a real negative number at this point. So what happens if b squared minus 4ac equals 0, let's say? So if this thing equaled 0 in here, then this whole bit inside would disappear because that whole thing equals 0. So can you see you just get x equals minus b, that's this bit, plus or minus 0, so it doesn't make any difference, over 2a. So you just get one value for x. Okay, so that's why we would say one repeated real root, because we know there's going to be two roots, don't there? Because ax squared plus bx plus c, as there's a squared in the as your highest power, that would mean two roots. Whereas if you had ax cubed plus bx squared plus cx plus d, so this is a cubic, you know this is going to have three roots, etc. Okay? So this is why we call it a repeated real root, because essentially both roots are in the same place. And that would be our x equals minus b over 2a. And what happens if b squared minus 4ac is bigger than 0? Well, if b squared minus 4ac is bigger than 0, then this thing, if we write this again, minus b plus minus square root b squared minus 4ac over 2a, this thing in here is a number, and as it's bigger than 0, it's positive. So let's say this thing in here equaled 4. So we'd have x equals minus b plus or minus the square root of 4, which is 2 over 2a. So therefore x is minus b plus 2 over 2a. There's solution 1. And then x equals minus b minus 2 over 2a. There's solution 2. So the point is, it doesn't matter if it equals 4 in there, or it equals 100, or it equals pi. You're going to get two solutions for your x's. So that's why we would write two distinct, because they're different solutions, real roots, okay? And that means, in practice, that your graph of your quadratic equaling 0, it means it's going to cross in two places, okay? So that's the history of the discriminant. This video is a little bit longer than normal, but that's okay. So b squared minus 4ac, we need to identify what's a, what's b, what's c. So every single time you want to make your quadratic in this form, ax squared plus bx plus c. So if it's not got this x squared bit at the front, the x next, the constant next, then make it look that way, and then you can easily identify what's a, b, and c. So the number next to x squared is a. So the number next to x squared is 2, okay? And the number next to b, the number next to x is plus b, so the number next to x here is plus minus 8. And the number without any x's in it is your c value, so that's plus 8. So b squared minus 4ac, in this case we know b is minus 8, so remember to put the brackets around that minus 8, because if you just write minus 8 squared in your calculator does 8 squared, and then times it by minus 1. So make sure you put this in brackets. So b squared minus 4, lots of a, well we said a here, there's a, b, and c. So a is 2, and c is 8. So minus 8 squared is 64, minus 4 times 2 times 8 is 64, so therefore this is 0. And remember what we concluded, if it equals 0, then we say we have one repeated real root. Okay? Cool. And then next two, much quicker. Sorry I took so long explaining that stuff. So again, we rewrite this, or we make sure it's in the form of a quadratic equaling 0 with a, b, and c in the right place. So our discriminant, b squared minus 4ac equals, well, what's b? B is the number next to x, including the sign, okay? So that's minus 3, remember all in brackets, minus 4, lots of a, which is 3, and then c, which is 18. So minus 3 squared is 9, and then we've got 9 minus 4 times 3 times 18, so we've got minus 207, which is definitely less than 0, and therefore as it's less than 0, remember you would be in the quadratic formula square rooting a negative number, which we can't do when we're talking about real numbers. Therefore, we would say no real roots. And remember what that means in practice. It means the graph, the quadratic, does not cross the x-axis. Or if you had one graph equaling another, like this part C, okay, if you moved that all over and made it all equal 0 and you found you had no real roots, it means that 3x squared does not cross 2x minus 4, okay? That's what we mean in the context of roots. So in this case, we need it in the form ax squared plus bx plus c equals 0, like normal. So we'll write that in that form. There's a 3x squared. We need to take the 2x to the left, and we need to add 4 to the left. And then we can say what our a, b, and c is. So b squared minus 4ac, always quote the formula. What's b? Well, it's minus 2, isn't it? It's the number next to x, all squared, minus 4 lots of a, which is 3, and 4, which is your c. So what does that equal? So we got minus 2 all squared, which is 4, minus 4 times 3 times 4 is minus 44. So again, this is less than 0, and therefore we would write no real roots. But just understand the context of the question. It means that 3x squared does not cross 2x minus 4. Or it means that 3x squared minus 2x plus 4 does not cross the x-axis. Okay? End of video.